Hey everyone, and welcome to our next live session on TCS NQT preparations. So, before we begin, as always, let's just start with this. So, just remember, this is our live sessions on YouTube that we have on TCS NQT. So if you have any queries throughout the session, whenever whatsoever, you can feel free to ask the same question because I will be going through the live chat throughout, so I can answer any of your questions that may arise. So just to recall, we have already done a few videos on aptitude as well as MCQ, that is in technical preparation for NQT, over the last 6 videos. In today's session, we're going to take a look particularly at programs that you can expect when it comes down to TCS NQT. What are the kind of programs you can expect? How do we solve it? What sort of questions do we get? And so on. So before we start with this, let's just begin with something very simple and something we should know. In TCS NQT, you're going to have 2 programs to solve. And to solve these 2 programs, you're going to be given exactly 45 minutes of time. So that's good amount of time to solve 2 programs. And these programs will not be complicated. These programs will be based on some basic concepts which you just need to implement things like arrays or some simple concepts like concept of prime numbers, a concept of palindromes, or some simple logic, simple logical concept which is modified to make a slightly different program. So in other words, if I have studied a program, if I have learnt, let's say, the code of a program to find whether a number is prime or not, the interviewer, in this case the compiler, the question that we may get could be something like this: given 2 numbers like 3 and 25, print all the twin primes between them. I'm just giving as an example. This is not the question we're going to solve, but I'm just giving you an example so you can understand how different the questions could be compared to what you may have studied. We generally know how to solve, how to figure out whether a number is prime or not, but here the question is, given 2 numbers A and B, find out all, let's say, every single twin prime between these 2 numbers. Now think of this. Twin prime are prime numbers which have a difference of 1 between them. 5 and 7 have a difference of 1 between them. 11 and 13 have a difference of 1 between them. That is, when you subtract them, you get 2, but have a difference of 1 number between them. 17 and 19 as well. So all these numbers are prime and the difference between them is 2. So such numbers are called twin prime numbers. So you will be given a question like this where you're supposed to figure out twin primes between any 2 given numbers. Such questions you can expect. So similar to this kind of logic, the other thing you need to know when it comes down to programming grounds is that for all your programs, you need to know 3 things very carefully. You will not be given the whole program to write. This is the first thing you need to know. You don't need to write main function. You don't need to write all these things. You will not be given the whole program to write. You will only be given a function to write. The input will be a parameter to the function. You will only be asked to write that function, and they will ask you either to return something from the function or print the results on the screen. One of these will be asked. Again, only a module of the code will be given. You will not be asked to write the entire program. In that module, in that function, input will already be provided. The brackets of the function will be there. You just have to fill in and complete, like, basically the code within it. That is all that you need to do. That's what you can possibly expect from this. Now, with this idea clear, let's quickly move ahead and take a look at one possible question that you can get in today's session. But before we start with that, there are a couple of other things that you also need to know very, very well. That is as follows. For any question, you need to know and remember 3 things very well. One is called time, another is called space, another is called test cases. So these are the 3 things. Before I go ahead, I have one question. How do you study of data structures and algorithms are needed? See, when you talk about data structures and algorithms, even if you don't know the coding of it, you should know the entire logic and working of it. At least you should know the coding in terms of, let's say, for example, if you're, I'm just taking one example. Let's say you want to learn linked list. For instance, I'll get back to this immediately after answering the live chat question. Let's say you're working on linked lists. In the idea of linked lists, you need to know what are double linked lists, what are circular linked lists, what are the different kinds of linked lists, what is the space complexity, what is the time complexity between of them, and what is the simple code to create an element of linked list or something like that. At least this much are to be known. Even if you don't study, even if you don't work practically on code like let's say reversing a linked list or something like that, even if you don't do that, at least, at the very least, at the very minimum, for each data structure, you need to know its basic implementation code. You need to know its different types, modifications. You need to know its complexities, that is space and time complexity. And you need to know its real world implementation, where exactly these are used in real world. So these are certain things that you would need to know. So if they ever ask a question, like for example, there's a movie ticketing system. What kind of data structure will you use? It's a very simple thing. You're going to use a queue. First come, first serve. The first one who's going to enter is going to be the first person who's going to go get the ticket. But if they ask you something else, something very different, instead of something like simple queue concept, if they ask you something entirely different scenario, like for example, you're going to need to store certain, let's say, lottery tickets. And whenever you take out a lottery ticket, you have to take out the lottery ticket with the minimum number only. Maximum number of lottery tickets should only be taken at the end. It should not be taken at the start. So in such a scenario, to take the minimum number first and maximum number at the end, we can use a min heap. I'm just taking a simple example. So like this, you can get a clear idea of this. I have, okay, comfortable with arrays, strings, linked lists, and also solved questions on lead code and GFG. Is it sufficient for the exam? No matter how much you study, I would never say it's sufficient, because we get competent, we get overconfident when anybody says it's sufficient. So I would always say the more you study, the better it is. For data structures, take a look at questions in various other websites as well. You'll get a lot of books also on data structures, particularly, especially if you haven't gone through trees and graphs. I would suggest you to go through those as well, because in the demo test of TCS NQT, if you observe in our last few sessions that we have taken live, we have solved questions particularly on binary search tree as well and graphs as well. Simple theory concepts based on binary search tree as well as graphs as well. So that is why I would suggest you to most definitely go through these as well. Do not skip any of these. So try it. If you have time, go for more. If you don't have time, if you have to learn something else, that's fine. But if you have time, spend as much time as possible to learn. That would be my best suggestion. Right. So let's get back to this programming concept. So when you talk about TCS NQT coding questions, you can answer this coding question in C, C++, Java, Python, or even Perl. That is totally your choice. Whichever language you basically want to take, it's going to be totally your choice. And whichever language you're going to take, you have to solve it in that. For each language, they will only give you a function where you have to just write the code. They will not give you the option to write the entire program. So in this, three things are of huge importance: time, space, and test cases. Your program should not take too much time. That is, the logic to solve the code should be quick enough that it shouldn't take too much time. Like for example, I'll give you a very simple example to understand this. Think of this. If I want to find whether a number is prime or not, a number could be prime number like 1079. I'm not sure whether 1079 is prime or not. I'm just taking some example here. Let's assume 1079 is prime. In such a scenario, what we do in our logic is we start dividing it from every number from 2 to 1078. So what happens in that case? From 2 to 1078, since you're dividing from every single number, you get to realize that you're taking too much time, too much effort, because for any number, the largest divisor that is smaller than it is the number by 2. So for 1079, if it is a prime, if you can go from 2 till n by 2, this takes smaller amount of time to figure out whether it's a prime or not, prime number or not. So this is where you get to figure out that your time complexity or time taken by your program is high or low. So we basically reduce the time to find whether the number is prime or not by half, because we reduce the number of comparisons by half. So this is how you can think of certain scenarios where time is of utmost importance. If your program takes too much time to execute, then the program isn't worth it. Somebody else who takes lesser time will have a higher chance of getting through. That is one scenario. Before I go on to space, Pratham, absolutely right. So when you talk about the algorithms, yes, greedy and dynamic programming, all of these are basically important. I mainly spoke from a data structures perspective, but yes, when you speak from algorithms perspective, you obviously need to know something like backtracking, greedy algorithms, dynamic programming, some basics of this, at least one example of each, so that you have a clear idea if any question is asked there, like if Dijkstra algorithm is asked, like which technique does it belong to, or if a question is asked like there's Floyd cycle finding algorithm, which technique does it belong to? So you should be able to just answer at least which technique it belongs to. Like, does it belong to greedy technique? Does it belong to some other technique, and so on? So such questions can also be expected. And since you never know what can be expected, it always pays to learn as much as possible. So let's move ahead from time. We got to look at how time is important. The next part that's hugely important is space. Your program should not take extra space. I'll give you a very simple example to understand this. Think of this. Take an example of a palindrome. I'll give you this scenario. I'll take this string, never, odd, or even. This is a palindrome. Pretty simple and clear, because when you reverse the string and you compare the characters, they are same. When we reverse the string, we get the same thing. From right to left, when we read it, we again get the same exact string called never, odd, or even. That's exactly what we will get. Now, in this particular scenario, here's my simple question. If regardless I'm getting never, odd, or even, since it is a palindrome, if I want to figure out whether it's a palindrome, what I need to do is take my original string, reverse the string, and compare my original and reverse of the string if they are equal or not. If they are equal, I can say it's a palindrome. To avoid this extra space usage, to avoid this extra memory of copying the string, what we can do otherwise is say that whenever a string is palindrome, we know it's a mirror image. A mirror image as in the left half of it is a mirror image of the right half of it. So we can take one character pointer pointing to the first character, another variable pointing to the index of the last character, and we keep comparing them. Is I and j equal? Yes. Then increase I, decrease j. Are they equal? Yes. So increase I and decrease j. Are they equal again? Yes. So increase I, decrease j. Are they again equal? Yes. So again increase I, decrease j. Are they again equal? Same logic. Increase I, decrease j. Are they again equal? Again exact same logic. Increase I and decrease j. Again equal. Increase I and decrease j. At one point of time, I becomes greater than j. So you have reached the half. You have reached the middle. Since you have already reached and crossed half of the string, you can say right now that your work till half of it is done. You basically can say it's a palindrome. You don't need to copy the string in reverse, paste it somewhere else, and do n comparisons. For n characters, you don't have to do n comparisons. Since a palindrome is a mirror image of itself when it is split into half, you can take first half and compare with second half. You don't have to create a new string. So space is also reduced, and you only have to do half the number of comparisons. So time is also reduced to solve this. So this is how you can think of reducing time and space within your programs. The better your logic is in terms of space and time, that is, the lesser the time and space, the lesser the time in seconds and the space in terms of bytes your program takes, the better your chances are in being in a higher ranking in the coding solutions. Now, followed by this, there's one more final important thing that is called test cases. Most of us don't realize this. For every question that has been asked, the compiler will check online with some inputs. The compiler will automatically check. Sorry, guys. The compiler will automatically check for some 10 or 20 or 30 different inputs to see whether your program works or not. So these inputs will help the compiler figure out whether your program is good or not. So think of this. I'll just give you one simple scenario. When a string is asked to check whether it's a palindrome or not, if you take a single character string, it's a palindrome or not? What do you think? We don't think of single character scenario at all. We don't think of this case at all. If it's a single character, is it a palindrome? Yes. From left, whether you take the same string or whether you reverse the string, it's the same thing, right? So if you did not think about this as a separate scenario and you created a code where you didn't think about single character, then your test case for single character will go wrong. So such scenarios may happen. I'm just giving this as one example. Or take one more scenario. You want to find whether a number is prime or not. When you're dividing by certain things, even if your program says minus 23, is minus 23 divisible by any number from 2 until minus 2 until the rest of the numbers? No. Since it is not divisible by any other number, if you say minus 23 is prime, then your logic is wrong. So there are certain test cases like this that may occur. Test cases are generally asked in interviews as boundary scenarios. That is, if a string is palindrome or not, what happens if the string is empty? What happens if string is one character? What happens if string is too long? Will your program work? So these boundary cases are often checked. If it is number based, what happens if input is negative? What happens if input is minus 1? What happens if input is 0 or 1? What happens if input is the largest integer available? So in such cases, some test cases will be provided where your program is compared. So whenever you write your program, check whether your program works for these boundary cases first. Before even solving this, please make sure to check whether your program works for boundary cases. If it does not, use an additional if condition to indicate that if there is a boundary case, what should be done. Do some things like this, which will ensure that your program will work even for boundary cases. So that is what I would suggest. So if you focus well on these three things with your logic should take the least time possible, your logic should take the least space possible, and it should clear as many test cases as possible. Even though it takes a little more time and space, that's totally fine. Your first priority, make sure you just create the code, you just create the solution, and make sure it passes as many test cases as possible to begin with. So that is the first few suggestions that I would like to give. So with this idea, let's take one of the common interview questions that has been asked over time. This particular question is called array leader program. So generally your question will be given as something like a story type. So this is how they have written it as a story. So numbers, just like people, have leaders and followers. So these numbers exist in arrays. So they're just using the concept of arrays to say that there are some numbers in arrays as leaders and some numbers in arrays as followers. We don't know who are the leaders, we don't know who are the followers whatsoever. So that's exactly what we need to take a look at here. We literally don't know who are the leaders or followers. So the question goes like this. An element in the array is a leader if, under one condition, if it is greater than all elements to the right of it. That's it. An element is a leader if it is greater than all the elements to the right of it. So all you need to do in this particular program, in this simple program, is use read an array. So after reading an array, find all leaders of the array and print them. That's all. Simple question. So it sounds slightly complicated, but once I give you a simple example, you'll find it to be very, very easy. Now take this scenario. I'll give you one particular array like this. Let's take 1, 12, 13, 6, 7, 4, 3, and 2. Now let's start from the first element. Is it greater than all the elements to the right of it? No, 1 is not greater than all the elements to the right of it, so it's not a leader. Is 12 greater than all the elements to the right of it? Again, not a leader. Is 13 greater than all the elements to the right of it? Absolutely yes. 13 is a leader. Now, just by looking at 13 and saying 13 is a leader doesn't mean that's the end of your program. That doesn't mean it's the end of your program. 13 is one of the leaders. 13 is greater than all its right elements. Absolutely true. Then, is 6 greater than all its right elements? No. Is 7 greater than all the elements to the right of it? Yes. To the right of it, you have 4, 3, and 2. So, 7 is also a leader because 7 is greater than all the elements to the right side of 7. Then, can I consider 4 as a leader? What do you think? You can let me know in the live chat. Should we consider it? Should we not consider it? Of course. Simple logic. 4 is greater than all the elements to the right of it. 4 is greater than 3 and 4 is greater than 2. So we can directly say yes, 4 is a leader. So I can say 4 is also a leader. Then 3, is it greater than all the elements to the right of it? Yes, 3 is also a leader. 2, is it greater than all the elements to the right of it? Since it's the last element, it is greater than every other element to the right of it. It doesn't make a difference. So 2 will also be considered as a leader. So there are 5 leaders in this array. So these are the elements we need to print space separated on the screen. That's the idea. So they're going to give you an input like this. And to be very clear, your input, you will not be given main function. You will not be writing main function. In main function, they're going to take an array of, let's say, 10 here, something like, I'll just take the same values as we took here. We've taken 1, 12, 13, and 6, 7, and 4, 3, and 2. This is the input we've taken. We're going to take the same example here. Now, with this particular input example, they're going to call a particular function like print leaders. And they're going to send the array and they're going to send the number of elements in the array. If you take a look at the number of elements, there's 1, 2, 3, 4, 5, 6, 7, 8, 8 elements. So I'm going to send 8 directly here. In this function called print leaders, you will be given the option to write the code. They will just tell you to write your code here. The rest you will not be able to edit. Either you will not be able to edit or the rest will not be visible at all for you. One of these two will be the scenario. Now, we are sending an array here. Whenever we are sending an array, we have to receive it as a pointer. Either a pointer or with brackets, up to you. Then we are sending a number. We are receiving it as int n as well. So with this idea, we need to find the leaders of this array. There are multiple ways to solve this. Again, remember, the way you need to solve this is by using the least time possible and the least space possible. Now, if I want to solve this, let me explain. If I want to solve this using the traditional method, using the simple brute force technique, my first logic is I'm going to take the first number. I'm going to check if it is greater than all the numbers next to it. So it could be, it just could be, you never know. 1 could be greater than all the elements next to it, but it's not. So let's leave it at that. We're going to take 1. Is it greater than the next number? No. Since it is not greater than 12, we will stop right there, will not continue further on. Let's take the next element. Remember, the condition is that you have to go through each element and find whether it's a leader or not. So I'm going to go through each element and check whether it's a leader or not. Is 1 greater than its next element? No. So I don't need to compare at all. So let's take this as index 0, 1, 2, 3, 4, 5, 6, and 7. We're going to start with index 0. In index 0, we have a value 1. So one question, how to code in Python? Pretty simple and easy logic. Even there, they'll give you a function only. Even there, you'll get a function like define, let's say, print leaders of a list and number of elements or something like that. Even there, you'll get the same. So no matter what you use, they're going to do the same logic. The idea will be same. So no matter how you do, what I'm about to explain right now, the important thing is the logic right now. This logic, if you're good at any programming language, you can implement this logic. I will implement this logic initially in C because most of us are familiar with C rather than anything else. But you can compare this to any other language, convert this to any other language and run it if you'd like. It can easily be worked upon, right? So let's take a look at this. First thing I need to do is start with index 0. So since I need to check if each element is a leader, I need to repeat this for all the elements of the array. So I need to basically take a loop where I is equal to 0, I less than number of elements, I plus plus. And in each case, I need to check if array of I is a leader or not. To check if array of I is a leader or not, I need to see whether array of I is greater than all the elements next to it. So to do this, let's write the simple code and I'll tell you why that code is pathetically wrong after writing it. So the first scenario is I'll take an integer I and I'll consider it as for I equals 0, I less than n, I plus plus. This is where we are going through each index to find if it's leader or not. So when we go through each index, we need to find if it's leader or not. If I'm currently in array of I can be 0, I can be 3, I can be 5, anything. If I'm in an index array of I, how will I figure out if it's a leader or not? Any guesses? What logic should I do? What steps should I take? Think about it. At Ajay's question, 8th December. Okay, that's not too long ago. Do wait for it. Do also see online in Twitter and other social media if other people are getting responses and are like posting it out as well. That will also help you simultaneously. It will take a little time generally. Right. Anyway, here back to this. If I want to find out if array of 0 is, let's say, a leader or not, I need to compare it with all array of j where j is greater than I. That's the condition, right? If 1 is supposed to be leader, it should be greater than all the elements to the right of it. If array of I here is 0, if array of 0 is supposed to be a leader, then I need to take j equals I plus 1 because j should start from the next element. I need to start from the next element and compare if all of these are lesser than 1. That's the whole idea, right? So here in this scenario, I'm going to take one more variable called j. So all I'm going to do here is very simple logic. I'm going to take for j equals I plus 1. Think of this logic. If you're checking if array of 2 is a leader or not, we know array of 2 is a leader here. Pretty simple logic. How are we getting to know array of 2 is a leader? Because we are comparing array of 2 with array of 3, array of 4, array of 5, array of 6 and array of 7. We are comparing array of 2 with all the elements ahead of it. Since it is greater than all the elements ahead of it, I can say array of 2 is a leader. So all I'm doing here is if 2 is I am starting to compare with j where j is equal to 3. In other words, j is equal to I plus 1 and j keeps on increasing till n minus 1 and array of I should be greater than all of them. Only then we can say it's a leader. That's the logic, right? So that's exactly what we're going to do. At Ajay's question, again, you cannot guarantee completely. It purely depends on how well you have done as well. It depends on that also. If you are confident about it, wait for it. You never know. Then again, you cannot directly guarantee because it also depends on how well other people have done in it also. It depends on both, right? So take this scenario. For j equals I plus 1, j less than n, j plus plus. So here all that I'm doing here is go through all elements after index I. So initially I want to check if index I has a leader or not. To check if each index I has a leader or not, I have to go through all the elements after index I and I have to compare if our index I is greater than it or not. So all I'm going to do here is if array of I is greater than array of j, then go ahead with it. If array of I is not greater than array of j, we have to stop. So the logic is, instead of writing if array of I is greater than array of j, I will write if array of I is lesser than or equal to, because the condition is it's a leader only if it is greater. Only when array of I is greater than array of j, where I is the current index, j is the next indices. Only when array of I is greater than array of j, I can say array of I is a leader. If it is less than equal to, then I say array of I is not a leader. Since array of I is not a leader in such a scenario, what I'm going to do here is break from this inner loop. Break will exit the j loop. That's all. Now, take two scenarios. Take two examples here to understand what exactly is happening here. I'll take one case, array of 1, and I'll take the other case, array of 2. Is array of 1 greater than its next element? Array of 1 means consider I is 1. If I is 1, j will start with 2. Is array of 1 greater than array of 2? No. Since it is not, since array of 1 is lesser than or equal to array of 2, we exit this inner for loop and come outside. That is what happens. So when array of I is not greater than or equal to, not greater than array of j, we are exiting the inner loop. However, when it is greater than array of j, in case of array of 2, in case of array of 1, it's not greater than j. So j will remain as 2 only. Since it is not greater than 13, we are exiting. However, take array of 2. Is array of 2 greater than the j value? As if I is 2, if our current index is 2, we need to compare it with all the right elements, right? That's what we are doing. We are starting with j equals I plus 1. If I is 2, j will start with 3. Is array of 2 greater than array of 3? Yes. So increase j. Is array of 2 greater than array of 4? Yes. So increase j. Is array of 2 greater than array of 5? Yes. So increase j. Is array of 2 greater than array of 6? Again, yes. So increase j. If array of 2 greater than array of 7? Again, yes. So increase j. Now when j becomes 8, how many elements do I have in my array? 8 elements. Since I have exactly 8 elements in my array, when it successfully exits, when this condition never occurs, this condition fails. When array of I is always greater than array of j, your program keeps continuing, keeps going on until j value becomes equal to n. And when j value becomes equal to n, that is when it will exit naturally, because array of I was greater than all the elements ahead of it. If array of I is not greater than any element ahead of it, we are exiting right there, so j will not be equal to n. So what I can get to figure out here is, if j is equal to n, I can say that my element is a leader. So I'm gonna print %d comma array of I, indicating that it's a leader. So this is the simple logic that we are doing. So I'm just gonna execute this. Let's see whether it works or not. If you guys found this simple and easy to understand, you guys can let me know. So our example was this. So we got 13, 7, 4, 3, 2. All of these as leaders. So in our output also I'm getting the same thing. That is 13, 7, 4, 3 and 2 are the leaders. I hope you are able to understand this code very simple and easy. I hope it is very simple and easy to everyone. If you find it too difficult, please do let me know, to everyone. But I hope you are able to understand this very easily. Since many of you are already in live chat, I request you guys to just let me know by one little text if you are easily able to figure out this logic or not. So this is your simple logic to find whether each element is leader or not. However, this is not of the best time complexity. It does not solve very quickly. I'll explain why it does not solve very quickly. Since you're going from left to right, you're basically checking every element. At Yeshu, alright, we'll go ahead with it later on. I think I still have one more logic to do. I still have to solve this with a better logic, better time and space complexity, right? So that's what we hope for. So let me solve with this logic, and you can convert this, or even I can provide this later on as well. Not an issue. So take a look at this in this scenario. So let's start with this from right to left. Instead of going left to right, I'm going to do it right to left. Why? Let me answer this. Now, When I go left to right, I need to check if 1 is greater than all the other elements. I need to check if whether 12 is greater than all the other elements. Here, when 13 is, let's say, a leader, I need to figure out by comparing all the elements ahead of it and then checking whether it's a leader or not. I need to do so much comparisons. I can improve this logic by going right to left. Think of this. Let me scroll down a little. Okay, think of this scenario. When I go from right to left, first thing I'm going to do is rightmost element I will directly say is a leader. I'll directly say 2 is a leader. After saying rightmost element is a leader, I will say my maximum element is 2. Understand this logic very, very carefully. I'll explain this in detail so that we go through the entire scenario once. Previous logic, look at this. How many times will outer loop run? N times. How many times will inner loop run? Nearly n times. So you can say worst time complexity could be up to n square. Will not exactly be n square, but you can say somewhat close to n square. That's the problem here. However, I'm going to reduce it to just n here. Now, I'm going to take the rightmost value, which is 2, and I'm going to directly say that it's a leader. After saying that it's a leader, let me mark it in circle saying there is a leader. I'm going to create a variable called max equals to, indicating that the maximum element till index 7. I will repeat, the maximum element from index 7 is 2. After that, once I go to the previous element, I will see what is the value. Is it greater than max? Max value is 2. Max value is 2. This is the maximum element after index 6. So the maximum element after index 6 is 2. So if my current element is greater than maximum element after that index, can I directly say it's a leader? Yes. So what I'm doing here is, now since 3 is greater than 2, my maximum element becomes 3 and I can say this is also a leader. Now I'll go to the previous element. When I go to the previous element, you take a look at this. Max is now 3. It is maximum of 6 and 7. Now take a look at fifth index. It has 4. Is 4 greater than maximum element of the next two? I don't need to compare with both. Previously, what did we do? If 4 is supposed to be found out, if 4 is supposed to be figured out whether it is a leader or not, I needed to compare it with 4 plus 1, I needed to compare it with 4 plus 2 until we reach the index n. Here I'm not comparing with two elements, here I'm comparing it with only one element, that is max of the next two elements, which is 3. So since it is greater than max of next two elements, I can say this is a leader and I can change max to 4. Next value, 7. Is it greater than the maximum of all the rightmost elements? Maximum of all rightmost elements is 4. Is 7 greater than that? Yes. So I can say 7 is a leader and I will update max to 7. Now 6. If I want to figure out whether 6 is a, let's say, leader or not, in worst case scenario, I need to compare it with all elements to the right of it. However, here, I just will compare with the maximum of all the right elements, which is already stored here. Is 6 greater than the maximum of all the elements to the right? No. There's one element which is greater than 6 here, that is 7. Since it is there, I can say 6 is not a leader and I will retain max as 7 as it is. Now we'll go to 13. Now remember, when we started left to right, when I is 2, I had to take a variable j which started from 3, then 4, then 5, then 6, then 7. I needed to check 5 values to compare if 13 is a leader or not. But this time, instead of 5 values, I'm only comparing with 1. When I is 2, all I'm doing here is just checking if 13 is greater than the maximum element to the right. The maximum element to the right is 7. Since 13 is greater than that, I will update max with 13 and say 13 is a leader. Now 12. Is it greater than the max element to the right of it? No. Now 1. Is it greater than the max element to the right of it? No. So how many comparisons did we do? We did exactly 8 comparisons, which is much lesser than our previous logic. This is how you need to think of. This is just one example where I'm showing you how you can improve time complexity. So this was our previous logic. However, I'm gonna, let's say, just comment out our previous logic. and I'm gonna give you a new logic for the same. This is the previous logic. I'm gonna take the same function code and I'm gonna modify to create our new logic, which will be much more efficient. In our new logic, it's simple. Should I go from left to right or right to left? What do you think? Which is better? Depending on what we have just seen, to everyone who's already in live chat, what do you think? Going left to right is better or going right to left is better? I'll take two variables, int I and j. Should I be starting with 0 or should I be starting with n minus 1? That's our question. So we start from right to left. That's the easier logic, right? So by default, rightmost value is always the greatest compared to everything else ahead of it. Rightmost element is always a leader. Since rightmost element is always a leader, what I'll do here is directly write here one statement like print %d space the value that is array of n minus 1. Since the last element is already a leader, I'm directly going to print it. After directly printing the last element, now I will take one more variable called max. Max element will be array of n minus 1. The last element will be max. From here, we're going to start our logic. So for I equals, initially I will start with n minus 2. Why am I starting with n minus 2? Because last element is already a leader. I've already printed the last element on the screen and then put it in max. Now I have to check the previous element. The previous element is, if the last element is in index n minus 1, the previous element will be in index n minus 2. So the previous index I'll start with I equals n minus 2. Condition I greater than equal to 0, I minus minus. We reduce one at a time, and each time we reduce this, we just check if array of I is greater than max. If array of I is basically greater than max, then I'm gonna print array of I. Simple logic. If array of I is greater than max, I'm just gonna perform one simple operation. Print %d, that is array of max. Sorry, array of I, not array of max. Array of I, whatever that is, which is greater than max, and max will be given the new array of I value as we just did. This is the simple logic. Let's see where we went wrong. I've missed out a semicolon here. Let's see here, semicolon we've missed out. Let's update that and let's see whether this program works. If you take a look at this, you get the same numbers but in a different order and your output is still correct. So this is your simple program for this. This is your simple logic for this. I'm just going to share this over to you guys for reference, so you guys can access it if you guys would like. So you guys can access this particular program or anytime you would like. Probably use paste bin so that you can directly access it later on. And I'll just share this particular link as well for your reference. So let me just make it public and I'm just going to create this new paste and I'll just have this shared with you. So this is your entire simple logic of a program. So at Yashu, one of you have also asked me for the Python code for this. So I will do one thing. I'll update this link with the Python code later on, so you will be able to access it. For now, we'll just have this link shared in the chat window for you. So before we go ahead, I just want to ask you guys one thing. What do you think of this new logic that we found out? Instead of going through the regular old method, that is always go from left to right, didn't our new logic take lesser memory? Of course, it did take lesser memory. Since it took lesser memory, by comparisons also it took lesser time. This would be a more efficient method for you in terms of interviews. So this is how you need to figure out to make sure that your programs are right. And what if there are no elements at all? What if the array is empty? In such scenarios also you may need to give a couple of test cases, test conditions. So once you're able to do that, you should be able to easily solve such questions. So these are the kind of simple questions you can expect when it comes down to these NQT tests. It won't be too complicated. It'll be as simple as these. So keep working on questions like these, keep working on programs like this. We'll catch up in the next session and we'll do a couple of more programs similar to this in the next sessions as well. Hopefully, you may get the same program or a very similar logic, which makes it easy for you. Even if not, the logic will definitely help you out. So, with this, we'll sign off here tonight, and I hope you guys keep continuing to prepare by going through lots and lots of concepts and topics which you have already gone through in our previous sessions. If you haven't gone through them, please go through them. They'll be hugely helpful for you guys. With this, we'll catch up in the next session. Until then, have a good time. Take care, guys.